So, where was I? Before we were so rudely interrupted, I had just drawn a unit circle, and I was about to, whoops, I was about to calculate um, the point, the unit vector of the point that is at 5 pi over 6. All right, so this is pi over here. 5/6 pi, divide that into 6 pieces. We end up to that angle right there. So we want that vector that I've drawn. So what is that unit vector? That unit vector, well, you probably have. Well, go ahead and calculate it for yourself while you pause the video and then come back. And hopefully you have come up with the idea that we have gone over in the x direction. So I'm going to say v sub x is given by minus equals minus square root of 3 over 2, and v sub y is going to be 1/2. Apologize, so I'll put that down here. Square root of 3 over 2, comma, 1/2. Or, what's another way of expressing that? We can say that this is cosine of 5/6 pi. That's a 4. 5/6 pi, and the sine of 5/6 pi. Okay. And I'll leave it as an exercise to the reader to go ahead and calculate the magnitude and demonstrate that it is in fact 1. So we've been using x and y components to define the vector. We can also use the magnitude and the direction directly. Say a bone is thrown at 7.28 meters per second in the direction of 74 degrees above the horizontal. What is the vector of the velocity expressed as the sum of the x and the y components? The question we need to solve here. Let's move this over a little bit. So we have the x component is going to be this component of this. Let's back up a moment. I've drawn the vector for you already. Handy dandy. 7.28 meters per second matches that. And this 74 degrees matches that. So we want to know the x component. So v sub x and v sub y. And we have that the v sub x is equal to 7.28 times cosine of 74 degrees. V sub y is going to be 7.28 times the sine of 74 degrees. All right. And so we want to express it as the sum of the x and y components. So that means that v is equal to, let's see, 7.28 times 74 equals, times cosine of 74 equals 2 times I hat plus 7.28 times sine of 74 is equal to 7 times j hat. So we have that vector expressed as the sum of the x and y components. We could also just say this is, I should have done this intermediate step where we have 7.28 times sine, cosine of 74 degrees times I hat plus sine of 74 degrees times j hat. Maybe we put these in parentheses so that the I hats and j hats don't look like they're being taken as sine of, multiply all that times 7.28 and we get that vector. Note that this point in here is the unit vector, and this here is the magnitude of the vector. Right? Okay. I don't like the use of SOHCAHTOA. I think that slows you down. That's my intuition. Well, no, it's not my intuition. It's my experience. It's students who use SOHCAHTOA to find angles tend to be less effective than students who think in terms of the unit circle. I know, you hate the unit circle because it was pounded into your head at some point. But that is, in fact, the definition of what the cosine and sine are. So the direction that you've gone over in the x direction when you have rotated through a sine theta is the cosine theta. And the direction that you go up or down when you turn through angle theta on the unit circle is the sine theta. Now, the way I want you to think about it is that if you have an angle between two things, right, and you, let's back up a moment. Let's say you have a right triangle that is floating in space somewhere. Let's erase that, start again. Let's say you have a right triangle that is floating in space. Be careful to make this look like a right angle. Always make it look like a right angle. And you have some theta in here. And this has some magnitude. We'll call it 14, just because. The length of this side is going to be the sine theta, because we are going up. We'll come back to this maybe in a moment, times the length of this, 14 sine theta. Now, the reason I'm doing this is that if I know that this side has length 14, then I know that this side that I have the arrow pointing at is going to be 14 times whatever we came up with for sine theta. So now I have completely skipped the fact that we have the side opposite over side adjacent. And I've gone right to giving us a number, 14 times sine theta, or maybe this is like 20 degrees. And we don't have to do that intermediate step of thinking about SOHCAHTOA. So if you have, the way I remember whether we're using sine or cosine rather than SOHCAHTOA, which is confusing, is that if we have the vertical thing that we're looking at, we can imagine it being a sign that says stop. Or maybe it's a sign that's hanging from the ceiling that says exit. So up or down is going to be the sign. I know it's spelled differently. It's just a mnemonic. The side opposite is always the sine because it's going up and down. And the cosine is the other one. So if we have an angle going off this way, and we have this is the right angle here, right? And we know that this length has magnitude x, and we want to know the length of this side here. So this is not the sine because it's not going up. This is up relative to our right angle. It's not going up, so it's going to be a cosine. So the length of that sine, length of that side, is given by x times, let's put theta in there, times cosine of theta. That's the length of that side. Put L equals. All right, that's the way I want you to think about finding the length of these sides. Don't use SOHCAHTOA. All right, enough of that. Moving on. What was I getting at here? Oh, I don't remember. It's probably the same thing. Just saying that this is going to be 2 and 7. Magnitude is 7.28. Angle 74 degrees still. All right, moving on. Okay, so our ordered pair here, which I guess I did that up above. So this ordered pair is going to be 7.28 times cosine of 74 degrees. And this one is going to be 7.28 times the sine of 74 degrees. 74 degrees. Where does it cross the unit circle? Well, that gets really easy because it crosses at the sine and cosine. So the unit vector, which is indicated here, I'll make this v hat. I'm not going to draw on there because I can't write that small. V, I make space bigger. Here we go. Let's do that. Bigger. Oh, that's as big as I can get. Okay, so we're going to write in here cosine of 74 degrees and sine of 74 degrees. Right? And that is v hat. Cool. Straightforward. Oh, we can have that here. So we can write that here. Cosine of 74 degrees and sine. Let's use a different notation. Oops. I'm going to say that this is cosine 74 degrees times I hat plus sine of 74 degrees times j hat. That is my v hat vector. And v is simply 7.28 times v hat. I can write that in. Well, let's go ahead and be explicit. Cosine 74 degrees I hat plus sine 74 degrees j hat. Close parentheses. Another parentheses there. All right, scalars. A scalar is simply that which scales a vector. It is a number, like you're used to numbers, real numbers. Yeah, real numbers, maybe imaginary numbers sometimes. Let's stick with real numbers. 532 minus 0.2, pi minus the square root of 2, or the magnitude of vector v. All of those are scalars. These are numbers without direction. That's why they're called scalars. So there's two kinds of numbers, the vector and the thing that scales a vector. Here's some practice for you. I leave that as your exercise. Make sure to do those. Make sure you're able to do those. And I will see you in class. Bye-bye.